Hi, so my name is David Well, and I'm going to give a talk about robotics, IoT, and artificial intelligence, with particular reference to the BBC microbit. You can contact me, David, at thinkingbinaries.com, and I'm also on Twitter at WileyGeek. So, who am I? I'm really, by trade, I'm an embedded software engineer, 35 plus years experience. So I design lots of software that goes into devices that you wouldn't think had computers inside them. And I've been quite heavily involved in education over the years. So I did actually many years ago teach A-level computer science at a local college, and I've run training departments, and I've done quite a lot of CPD for teachers over the years. I'm a school STEM ambassador, so I go into schools and help out with science clubs and computing clubs. I wrote a book, I co-authored a book called Adventures in Minecraft, which is a kids coding book learning how to code in Python using Minecraft as the vehicle by which to teach Python. Remember the IoT, so I wrote a number of the microbit resources for the Faraday challenges, and you will find me in the links below at the bottom of the page there. I also spent quite a bit of time, excuse me, quite a bit of time working with the BBC Microbit team in the very early days when the microbit was being designed, and that was through my involvement with the IET. And then that led to me working for the Microbit Educational Foundation for a couple of years. I was frontline support, and also did some time in the education department. And while I was there, I got branded as the Microbit Wizard because I've done quite a few large and wacky projects using the microbit. So what is a microbit? I'm sure most people know now, but so there's a version 2 out, so let's just look at the differences. Version 1 was released in 2015. Pocket-sized codable computer with 25 LEDs, 2 buttons, a built-in accelerometer and compass for gesture sensing, and the gold pins at the bottom can be either connected to directly with crocodile clips or plugged into an edge connector to add on accessories. Has resistive touch sensing, so you have to hold 2 pins to complete the circuit. It's a bit like Makey Makey. There's onboard temperature and light sensing, Bluetooth radio, so you can pair it up with your mobile phone or your tablet, and that Bluetooth radio can also be used as a peer-to-peer radio between microbits, which is good fun. And it's coded in MakeCode, which is a JavaScript-based editor, MicroPython, and also C++. Version 2, which was released in October last year, has an additional speaker, microphone, capacitive touch sensing, so this is a single point of contact, so you can touch any of the numbered pins at the bottom. You can also touch the logo, so the little face logo is touch sensitive. It's got a much better CPU, more memory. It's got a power down mode, so you can actually hold the button and it powers down even while the batteries are plugged in, and it's fully backwards compatible with the version 1. And it's worth saying that the team spent a huge amount of effort keeping the device backwards compatible. So, robots. So one of the biggest robots I've built, if you can call it a robot, is a motorized radio telescope called the Lovell Telescope at Jodrell Bank. And this was a project I did with the One Show, BBC The One Show, and we had some children in a local school, and they built a model based around a small microwave dish, basically. And when the model was turned and tilted, it sent commands over a network to the controller of the Lovell telescope, and then that moved in real time. And we found a pulsar. So what happened was the thing moved around to a position in the sky, and it locked onto pulsar, and then the signal came back and was played through a speaker on the microbit. And in the links below, you can find the code that we did for that on my GitHub repository, and also a YouTube video of the One Show. And this was probably one of the first projects we did with multiple microbits. So we had 3 microbits connected via USB cables to a Raspberry Pi computer, and that Raspberry Pi computer was then connected over the Ethernet cable to the central controller of the Lovell telescope, and we could drive the Lovell telescope. We could also drive one of the smaller telescopes as well to do some testing with. Slightly smaller robot. So through the work I do as a STEM ambassador in schools, we went to the Pi Wars Cambridge competition a number of years running, and this is Murat building the robot on the day. And one of the things we wanted to do is we wanted a wireless controller. And we decided to build a wireless controller up to microbits because we knew that microbits could send messages to each other. And I recently did a project that you can find on YouTube where I made this a bit more standardized, but basically the controller microbit, you tilt and it will send radio messages to a receiver. The receiver is plugged in via USB to a Raspberry Pi, and the Raspberry Pi then drives the motors. In the subject of internet connectivity and radio messaging, so one of the big networks of microbits we did was at the BET Education Show in London at the Excel Centre. Johnny, the CTO of Microbit, and myself, we built a thing called a tone matrix, which is basically a 5x8 matrix of microbits. Each microbit represents one note in a repeating pattern. And then what happens is that a Python program on the Raspberry Pi connected via microbit over the radio network scans the buttons, and whenever a button is turned on, it updates its internal view of which button is on and off in the matrix. And it uses 5 recorded wave files and it plays those back. So you can basically live, you can press the buttons on the microbits, then as the sequence rotates around, it will play music. And that's basically 40 microbits communication over radio. And there's a video on YouTube about that. And if that wasn't big enough, we then went even bigger and we built a 192 microbit IoT network out of microbits with the BBC Click Live show in London. And you can see Spencer down the bottom there holding the receiver microbit. And I wrote a Python program on my Mac that basically represented each person in the audience as one button. And they could tilt the microbit flat or facing up to turn that button on and off, and that turned off on and off a particular note in the sequence. And then basically the receiver microbit sent the messages back to the laptop. The laptop had a memory of which microbits it thought were on and off, and then it sequenced those 16 wave files. So we believe that was the biggest number of microbits ever communicating over the radio at the same time. There's some machine learning work that's going on with microbits. So Jan over at ARM did a demo at the BBC Click Live in 2020, where he got everybody in the audience to speak the word hello, and he recorded all these wave files of people saying hello, and he fed it into an edge impulse machine learning model, which basically trained the model to recognize the phrase hello. And then he built this model in with a recognizer into a microbit program, and then anyone could say hello to the microbit and a smile came up on the screen. And there's a blog about that he wrote on in the link below. Now, microbit is a brilliant device for educators, and it's a brilliant tool to explain how the world around us works, to learn about IoT, robotics, and how artificial intelligence they actually work, and really to imagine and invent the future. So let's look at some examples, some smaller examples of that. So one of the easiest ways to model Internet of Things is basically to send radio messages. And then you just say, well, the Internet of Things is just a bigger version of that. It's going over the internet rather than just between two devices. So here's a demo of 2 microbits. And there's this lovely feature that Microsoft put into the MakeCode editor called the multi-editor. And you can find it if you Google it, which allows you to have 2 microbits running either the same or different code. And this demo, which I'll give in the demo section at the end, basically you shake one microbit and then the duck disappears from that microbit and appears on the other microbit. And this is a really, really simple program to write, and it can allow children to basically experiment and model with radio messaging really, really quickly. And you get into some really interesting situations if you have more than 2 microbits, because then, of course, what happens is the duck disappears from one microbit and it appears on multiple microbits. And then you have some interesting discussions about, well, where is the duck? But the other thing that happens quite nicely is that we find that children engage with the whole idea of wireless range and, well, how is the message secure and what happens if the message doesn't get through. So it's really interesting discussions about networking with that. There's a link in the bottom of the slide there that you can go to the online example of this program and try it out. In robotics, so there's a number of great robotics kits out there. This is one of the very early ones that I got from Kitronic. The housing has been taken off, so it's just the basic model. And then what I did with the obligatory bit of blue tack, I stuck a micro switch on the front, and then I made a thing called a bump buggy. So what this does is this is an obstacle avoidance project, and it will move forward until it hits something. And then if it does hit something, it goes back and turns left for a second and then goes forward again. And eventually it would find its way out of a maze, basically. And the code for that is quite simple. You can see it on the screen. There's some links below about the products that I used to build that bump buggy with. And I'll give a demo of that later. AI. Now, I call this fake AI because it really is fake AI. And if you look up ELIZA on Wikipedia, you'll find all the way back in the 40s or 50s, I think it was, a program that looked to be intelligent, but it was basically just had a library of a few standard responses, and it would find trigger words in what you typed in, and it would you'd think it was intelligent if you were using it. Look at this fake AI. And there's a lovely little character in the Tron film called Bit, and Bit can basically say two things. It can say yes and it can say no. So you have to qualify your questions to it very, very carefully to get a yes/no answer. And I built a bit using the microbit. And what this basically does, if you look at the system diagram below, is a microphone. The code senses the level of the sound coming into it. When it goes above a particular level, it starts timing how long it is making a sound or not making a sound, and it will count basically. So if you say my name is David, it will count my name is David. It will get number 4. And then use the number 4 to feed into playback engine to decide, with a little bit of randomization, how to respond, whether to respond yes or no. It'll respond yes, no if it doesn't know what the answer is. And if it's really wants to say yes, it says yes, yes, yes. And it really wants to say no, it says no, no, no. And basically we use the speech engine built into the microbit to say the words yes and no, and a little bit of randomization. There's a YouTube video link there to the original Tron program that inspired the idea. And this uses the microphone and the speaker on the new version 2 microbit. Personality is another thing that's quite interesting. So I've done a number of games where just attaching a microbit to a physical object has taken that inanimate object and made it feel like it's alive. So it's not really artificial intelligence, but personality helps to make people think that the objects are a bit more lifelike. And two, the very fun games that I did with that in the early days were Perfect Pancakes and Catching Raindrops. And Perfect Pancakes is basically you have to flip pancake mix, in this case it's a fried egg, and what the microbit does is it senses the movement of the pancake, the little pan, and it uses that. And if you flip it too soon, then you don't get a very good score because you've messed up the mix. If you leave it too long, then you get a little animation on the screen that the mix has caught fire and you have to reach up and turn the smoke alarm off. But it builds some really lovely animations. So there's this idea of a sizzling pancake mix. So this cycles between these 3 screens. There's various animations that basically make the game come alive and make you think it's got some personality. And then I showed this to the BBC and they really loved it. But they wanted something that they could send to journalists for the launch of the original microbit, and they didn't want to have to buy a few hundred little frying pans. So they said, well, what can we make that shows the idea, but that isn't a pancake? Because they didn't want to buy lots of little frying pans. So I thought, well, everybody's got a coffee cup. So if you attach a microbit to the front of a coffee cup, which you can do with a bit of string or a bit of glue or something, then the idea is you hold the coffee cup and you tilt it left and right, and then a little image of a coffee cup moves on the screen, and it's raining. And the idea is you have to catch the raindrops. And again, there's some lovely little animations inside that of the cup moving and the drop going into the cup. And then if you catch too many drops, then the cup overflows and there's like a little animation on the screen. And there's a video link there that Michael Sparks and BBC took at the original launch event of me demonstrating. And then again, personality, this whole idea of like the eyes of the microbit at the end of the game, it blinks the eyes to let you know that there really is, there's some intelligence inside it. Humour is quite important as well. So I did a project for the version 2 launch. So the version 2 microbit has a speaker and a microphone. And the idea of mimic, or my mic, it can be said whichever way you like, is that you speak a phrase to it. And very similar to some of the other projects, it's got a level detector and it times the phraseology of what you say. It records those lengths into its memory. And then when you stop speaking, so after some time out, it then triggers playback. And what the playback does is it squeaks back at you in the same phraseology as you said, hello, my name is David. It goes, wee, 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 and squeaks back at you, almost like mimicking you. And it uses a sound synthesizer that I wrote many, many years ago for a project we did with Doctor Who, BBC Doctor Who, to make a sonic screwdriver. So it makes the squeaking sound. And it also has some lovely little animations on the screen. So humour is quite important. So if you make a robot and you add some personality and some humour to it, then it feels more human and people relate to them better. Where next? So today we've been having some talks about robotics. Sensing things around the robot, actuators and moving the robot around. Internet of Things, so you can use that for remote control, remote sensing, access to online databases to give access to more intelligence and knowledge access, those sorts of things. Artificial intelligence, so a robot can infer what is happening around it. It can make some decisions based on those. It can trigger some actions, and hopefully with all the machine learning, it can adapt to its environment. And then something I've slotted in extra is say that actually personality is important. So the humour of the device, empathy, the attitude it has, knowledge and skills that it has can basically bring more to the story. So the combination of robotics, IoT and AI with some personality. And what you get at the end, if you join all those together, is intelligent objects. So I'm thinking here of something like Pepper or Miro, which are devices that have been built that humans can relate to because they have aspects of all of those inside them. And there's a couple of links down there. You should definitely look at both Miro and Pepper. And what's the parting message? Well, really, I think the parting message is that the BBC Microbit is an excellent tool to experiment with all of those aspects, and great for educators and learners to use. You can model a lot of the ideas very, very simply with just a few lines of code. And the key thing here is basically to use devices that are easy to engage with to invent the future, so invent the world that you want to live in, really. And I've got 5 little demos, and these are all linked on YouTube. So if you're watching this not live, you can click on the links and see each of the demos. Chuckaduck is the idea of transferring data between 2 microbits with their peer-to-peer radio. The bump buggy is an obstacle avoidance buggy, so that's basically using a motor controller to drive the wheels and the robot and the sensor to sense its environment. Ask the Bit is the demonstration of using the microphone and the speaker in a sort of Magic 8 Ball like thing, but using not voice recognition but voice timing. Mimic is again using the version 2 feature of sound and microphone and speaker to basically introduce some humour into demonstrating what sound is about. And then I've got a robot controller, which is the code that I presented at the PyWars conference earlier this year, which uses a microbit as a radio-controlled controller that then moves motors around. So thank you very much for listening to my presentation. I hope you enjoyed it. If you've got any questions, please do send them to me.